So, hello everyone. Can you all hear me? Yeah? Okay. So, I will introduce you SSH hidden feature and how to improve your security with your SSH servers. So, I'm Antoine, I'm working at Algolia and I'm a security engineer. So, in the first step, we will have a look at the design. So, what we want to achieve and what most people, we will first look at what people do, and then we will have a look at what we want people to do. Then we will have a look at the main SSH to see if there is some help in their main SSH, and then we'll find the hidden feature. And we will finish by a little demo. So what most people do, so we will see what people are using as best and good practices, and how we can improve that. It will be the next topic. And what we do not want, because if you want to improve your security, you have to be focused on user experience, and you don't want to annoy people with too many security layers. So what most people do right now, most of the time they are connecting to their SSH servers with username and password. It's a good thing when you only have 1 or 2 servers, but as soon as you have a full infrastructure, it's not a good idea, because you will have to handle all users on all servers with their own password, and it's not the best way to do that. So you have a better way to do that, which is using SSH key pairs. And with that, you are able to connect more easily on the server. But there is still an issue, because you have to maintain the authorized key on all your servers, and it can be hard to maintain. So another thing is, most of the time you do not check the host certificate. I mean, every time you're connecting for the first time to a server, yeah, do you trust this fingerprint? Yes, of course, yes. I have no idea what I have accepted, but it's too late. And another thing is, sometimes in some company you can see that people are using the same account for doing administrative stuff on the machines, and it's hard to audit this thing. I mean, you don't know who really does the action or who really did, because most of the time when you want to know someone if he had done something, you look in your log. So the goal we want to reach, we want to use ephemeral SSH keys. I mean, it's a key that you will use only once, and it will be only valid. So it will be only valid for a specific time frame. It's, to give you a basic example, is like a credit card. You know, you have an expiration date on your credit card, so it's the same. You can see it as a virtual credit card you use on the internet, which is one shot. This is the goal we want to reach on our SSH configuration. So we also want to create temporary certificates. So it's the same as website. It's signed by a trusted root certificate authority, and it allows you to be sure that the people who is coming to your server is a good one. I mean, it's someone from your company who has been signed by your own signer. Another thing is certificates are only valid for a short period. So for web server, most of the time is 1 year. But here we will be more restrictive. I mean, in the design, we want the SSH key certificate to be only valid for 5 minutes before and 5 minutes after the generation. So we will also want to centralize user management. I mean, because I told you in the previous slide that if you want to have good audit of who did something on your servers, then you have to have an account per user. So you can use whatever you want, Active Directory, LDAP, whatever. It's not part of this topic, but for your information, at Algolia we are using an LDAP. even if it's not part of the main, it's not the main part of the talk. This has to be the source of truth for your design. I mean, everything in this directory has to be trusted by every other services. And the last part is that you have really to be scared about the SSH, the certificate alert when you connect to a machine. So, what we do not want our user to do? We do not want them to renew their SSH key every week or every day. It's very boring, and it won't improve the security because people won't do that. We don't want to make the login process more difficult. I mean, when you want to SSH to a server, you just write your SSH command and then you own your server. We want to keep it as simple, just one command more, and that's it at the maximum. We want to use configuration. We don't want to use configuration management to configure fine-grained authentication on server. I mean, we don't want to use tools like Puppet or Chef to generate authorized key file on the server. We just want the server to be able to trust the CA for the signer, and that's it. And the last thing, and not least, we don't want to re-implement our home crypto. It's just the best way to die in terrible pain. Because if you try to run, unless you're a cryptographer, then you can try, but if you're not, don't do it. It will end up badly. So here's the schema of what we want to reach. So you at the bottom, you can see the user. You have here a signer. I will explain a bit later what it is. Here you have the LDAP, so your source of truth. And then you have a CA key on the signer. So when a user wants to connect to a server, he will ask first a signer for a certificate. So the certificate will be signed by the signer using the CA key, and information about the user, because you have to store the public key of the user, will be stored on the LDAP. So here you have user information, like the principal is allowed to use on your servers. So for example, for me it will be Antoine, or maybe it will be root. Not a good advice, but it can be. So the signer is fetching your public key from the LDAP, is checking your password against the LDAP, and then if everything is correct, it will return you a signed certificate. With this signed certificate, you have now 5 minutes to connect to the server you want to administrate. So don't worry, you won't be disconnected after 5 minutes, because SSH is keep alive. So as long as you stay connected, your session is valid. So how can we do that with SSH? Because I don't know for you, but I've never heard about such thing like client certificate on SSH. I mean, the only thing I got in my mind was, okay, let's try to use a normal CA, sign the public key of the guy, and then, okay, then let's go. Let's connect to the machine and write a little wrapper against your SSH server to authenticate the user. But as I said, we don't want to implement our own crypto. So let's have a look. Here is the first result from Google when you type SSH keygen main page. The thing is, at the bottom, you can see that there is no track of certificate. So what to do? Then maybe we can try to have a look at more recent documentation from the OpenBSD website. And then we can see that certificate matches about 60 matches. So it seems that SSH have support for certificate, which could be a good thing. So let's have a look at the feature SSH can provide. So it's limited certificate functionality compared to real X509 certificates, but it's completely fine with what we want to achieve. What's more, in the certificate, you can enforce a lot of things, like is the user allowed to use a PTY? the command the user can run on your machine. So you can force the command into the certificate. So you don't have to put it anymore in the authorized key file. And because most of the time you always make a typo in the authorized key file, and finally the user is able to run everything or nothing. You can also enforce the principal of the users. So for instance, Antoine or root or whatever user you want him to connect. It's very useful to fine-tune the certificate. You can also restrict in the certificate the source IP of the incoming connection and the host name of the servers the guy wants to connect to. So it's quite very powerful. So validity is also supported. So you can, once the certificate is expired, then you cannot connect anymore to the server. SSH server are logging certificate ID, so it's something very useful because when you will look at your logs, in case of an incident, then you will know that that user used this certificate to connect to that machine. And it was introduced quite silently in OpenSSH 5.7, so quite a long time ago, because right now we are at 7.5, I guess. And I think they should have made more noise about this, because it's a very, very good feature. Because you can really protect your server. Because even if you have the good private key to connect to a server and all the authorization, then if you don't do the dual authentication through the signer, then you won't be able to access the server. So it's a kind of 2FA for SSH. So now that we know that SSH has all the features we need for creating a certificate, then we need to sign the public key to create the certificate. So how do we do that? Because at that time, you can use the command line from SSH keygen, but it's not really scalable when you want to have multiple signer, because you have multiple users and you want high availability and things like this. So the quick way to implement the signer was to use Go. I was completely new to Go before this, so it's kind of my hello world in Go. And they have implemented almost all of the SSH RFC, so which is quite a good thing. There is some missing parts, but it's only related to ciphers and to cipher suites, but the best ciphers are in the code, so it's perfect. We have no need to build our own crypto because we can trust people from Google. And it's easy to maintain and update because Go is quite simple to read, simple to update, and it's very easy to deploy. Now how do you get to a server then? First step, you have to request a certificate. So you connect to the signer, you say, hey, hello, I'm Antoine, my password is Toto, and then you get, if everything is valid, you get a certificate from your signer. At the moment, we have multiple clients. We have a Bash client, a Python client, and a Go client on the road. Then you will have to tell SSH to use your generated certificate with your private key. Because if you are only using your private key, then you will send to the server a non-signed certificate, which is your public key, and you won't get access to the server because the server won't be able to check the signature on your server, on your certificate. You will be able to use your own account because it will be put in the certificate. So all this information are stored in the LDAP. Then you do what you have to do, most of the time breaking the system, and then you're done. You can leave the server, and 5 minutes later, your certificate is not valid anymore. You cannot connect with this certificate. If you want to connect again, you have to request a new certificate and then connect. So let's try to do a short demo. So, okay. I don't know if you can all see. Anyway. So here I want to connect to a server. So first step, I said, it's to request a certificate. So let's go. So for this, we will use the Python client. Yes. Up. So we're using the Python client. So my LDAP username, my LDAP password. So everything goes fine. I mean, I have my certificate. So I have some debug information, but it's not really important at the moment. So the cert is acquired. So now I just have to add this little option to my SSH command, and I will be able to connect to the server. So let's try to connect to an Algolia server. So here, I tell SSH to use my new certificate, so my signed certificate, and then I want to connect to one of our probes. Up, I'm on the server and I can break everything, but I won't do that. So as you can see, I'm using my username Antoine, and everything will be logged with my username. So, yep. And if we want to have a look, so here's what you can find in the certificate. So you have the type, which is a certificate. You have the public key associated with that certificate, the CA which signed the certificate, the ID, so Antoine plus a random number. And then you have the validity. So it's valid for 5 minutes, only. Here are the principles I'm allowed to use with that certificate. So only Antoine in that case. And in the critical option is where you can restrict the source. For example, you can put the source IP of the incoming connection for the server. And in the extension, I allow me to use a PTY because it's better if I want to use a real terminal on the machine. And that's it. So where is the okay? Okay. So that's all for the feature. If you have any questions. Yep. You have to use the box.
Have you got any way to perform or how do you do for certificate revocation on the servers?
No, it's okay. I forgot I already have a microphone. Sorry. Yeah. Okay. For the certificate revocation, then the certificate are only valid for 5 minutes. So in case it's your CA which is compromised, then you just have to remove it from the SSHD config. Something I didn't talk about is in your SSHD config, you can have multiple CA instruction in the config file. So if you want to remove just one, then you just have to remove the line and all the other one will be still valid.
How do you do it at scale? I mean,
for deployment of the SSHD config, we are using Chef.
Do you have a public repository where we can find some example?
The source code will be public, but we have to review it internally before. So, but yes, it will be public.
Okay.
For the signer, yeah, of course. Yeah.
So how is access to that? I forget what you termed it, but the certificate serving server. How is access to that controlled and authenticated?
Sorry, can you say it again?
So the first server you connect to with your username and password
yes.
issues you the temporary certificate that allows you to SSH in. Then how is that first server protected?
This first server, this server has no information. I mean, it's only had read-only access to the LDAP. You get your personal information, then check that everything is okay. And if something goes wrong, it won't give you any certificate. But the server is not that protected more than with IP tables or things like this. So everyone in the company can use the signer.
to does it work? Yeah. So the signer is basically it's just HTTPS with some kind of authentication, like basic authentication to because you actually send your passwords to the server.
Yes.
And
it's a REST API, yes. And it's over HTTPS, of course, yes.
And you don't check the SSL certificate.
On the demo, you see the warning, yes.
Okay.
Because I'm using a demo environment, so it's not.
Okay.
But on the real case, yes, we're checking we're checking the remote certificate.
It's not really a question, but I'm surprised that there is not such a signer program already.
There is one made by Netflix, which is made in Python, and they implemented all the SSH RFC, and it's a lot harder to implement and to get. But if you want a quick signer, you can just do it with the SSH keygen command. Everything is implemented in OpenSSH. So the signer here you have seen is just to have a REST API over the SSH certification.
Okay, I'm sorry, and as we are running out of time, so if you have any more questions for Antoine, feel free to reach out to him after.
Of course, yeah.
Thank you, Antoine.